Hey, welcome Team Resistance to Program Apprentice Training. This is Jim Huffman. I've been around since 2012. Today we're going to look at functions, maybe do some improvement. So let's see what's up. Oh yeah, we're going to take a look at the even-odd challenge from last lesson. We're going to start cleaning up some of the program control and structures. And then we're going to recode the even-odd challenge and see if we can't even improve that. So let's get going. All right, so I'm cheating this time. By now you guys should know how to launch VS Code and how to open my new robot. So I've written the code. Let's just go ahead and review it. What is the code supposed to accomplish? Right? Add comments. Right? I like comments. So if all the DIs are off, all the DOs are off. If an even number of DIs are on, the green DO is on, all others are off. If the odd number of DIs are on, the red DO is on, all others are off. Right? But let's think about this now. The 0 is usually even, so we don't want to count that, right? So now we have three states. We have none, even, odd. We could have gone ahead and redone the code from the previous example and just said, you know, here's the even conditions, turn on the green light, else turn off the green light, test for the odd conditions, turn on the red light, else turn it off. But let's see if we can't, what fun is that? Let's try something different here. So think about that if no buttons are pressed, right? That's usually going to be the state. So let's test for that first, maybe improve the efficiency of the code a little bit, or at least the execution. So if no button, no red, no yellow, not green, right? None pressed, then we're going to turn off the green, we're going to turn off the red. All right? Else, well, we got two conditions after that, right? We've got the odd and the even. We're going to test for even. So else if, right? And we've got two buttons here, right? Yellow and green. We've got two buttons here, red and green, and we got two buttons here, red and yellow. So these are all the three even states that can be tested for. So if that's true, then we're going to turn on the green LED, else we're going to turn off the red LED. If either of these conditions are not true, right, we're going to drop down to here and say turn off the green LED and turn on the red LED, right? So that's the code. Well, that takes care of the red and the green. What about the yellow? Well, we only have to turn off the yellow one time, so let's do that up in test inning. Yellow LED set false, right? To do does not work. Yes, I found a bug in the simulator, right? So what I've done is, we're only doing this one time for test purposes. I've moved this code up to robot any. Remember robot any? When the robot is turned on, it executes the code one time, right? So we're going to turn off the LED at the beginning of the robot startup. So still digging into this. We'll figure it out. We'll let you know when I've got some more information. So let's test it. Let's go up here and start the simulator. We'll go ahead and compile down here. Build successful. Hal Sim. Click OK. And there's our simulator. Look, our yellow LED's already off, right? And if we come up here, let's come over here and hit test. Right? Hey, look, we've got 1, 2, 3 button's pressed and the red LED is on. So we have an odd, on. Let's turn one of them off. We got even. The green is now set. We turn off another one. We now have one button odd and the red is again set. Let's turn off the last one. Nobody's on, so all the LEDs are turned off. Let's go up here to the top, turn it on high. We got one LED. Therefore, the red LED, red button, we have a red LED set. We got a, turn on the second one, we got a high. So we got even, we got the green LED. So that code works. All right. Let's go ahead and close that. All right, so we've tested this code. But now we've got three different examples in three different areas of the main robot control. The autonomous, the teleop, test. Getting kind of crowded. And if the LEDs were just one subsystem of the robot, imagine if we had 6 or 12 subsystems. Now it's really going to get confusing and crowded. Let's start breaking it up. Let's move this code, the even odd code, down to a new process, a new function. And let's call it update LED even. Notice it's public, it's void. We're not going to return anything. We're going to move all this code down. So let's grab it. Grab everything but that last bracket, because that last bracket belongs to test periodic. So Control X, we move it down, Control V, looking good, right? Let's go ahead and test it, right? It should oh, wait a minute, before we do that, got to call it. So let's go back up here and test periodic, and let's call update even. There it is. Not returning anything, so we don't store it. We're not passing it anything, so we can leave it as is. Now let's go and try testing. Simulate code. Rebuild the code. Turn on our HAL GUI. And again, the yellow LED is off. Let's hit test. So we have an odd number. Odd number is high. We turn the first one off. Makes it even. It's now the green LED is on. We turn the yellow off. It's now an odd count. So the red comes back on. We turn off the red. And they're all off. All right. So you can go ahead and play around with that. That's should work. Let's go back. So we've got this all set up. All right. So this is looking good. I'd still like to see us clean this up though. Let's recode this as a count, right? We've got buttons 1, 2, or 0 actually, 0, 1, 2, and 3. So why don't we count the number of buttons? Well, I've cheated again. If we come down here, we see another one. I've copied the code down and modified it already. And it says if DIs are off, all are off. 0, right? If even, 2 buttons are on, then the green DO is on. If odd, 1 or 3, DIs are on, then the red DO. So the first thing we want to do is count, right? The first thing I did was create this LED update LED count. And now we're going to count the DIs. Well, if red button.get is on, then temp count equals temp count plus 1. Well, that's one way to do it. Well, if the yellow LED is on, we can use a shorthand for that. And it's temp count plus equals 1, right? Of course, we're only incrementing by 1, so why don't we just increment? And the shorthand for that is temp count plus plus, right? So we've created a variable called, that's an integer, temp count, and we've set it equal to 0. Then we say if the red's on, we add 1. If the yellow's on, we add 1. If the green's on, we add 1. Right? So when we get to here, right, we've got the count, the number of buttons that are pressed. So what do we want to do with that? Well, this switch says use this value and switch between these cases. All right? Case 0, which is none, we have both LEDs off. Break. Case 1 or case 3, right? Because what happens is, see the break? It says keep on going till you hit that break. So here we said case 1, if it's equal to 1, keep on going. If case is equal to 3, keep on going. Right? Gets down here, it's an odd, so we set the red true, green false. Break, jump out, and come around again. Now if the case is 2, right? It's not 0, it's not 1, it's not 3. It's 2, right? That's even. That's the only thing we need to check for. Then the green LED is true, the red LED is false. Just to be on the safe side, if something's wrong in the code and I pass it a 4, what happens? The default is always to turn the LEDs off. Your choice. We could have put the yellow LED in here and said, look, if you pass it the wrong number, turn the yellow LED on, all right? Turn the other 2 off, right? So a couple different possibilities. What do we have to change then to make this operational? Well, let's go up here into temp, periodic, test periodic, and change that to count, CNT. I like shortcuts. I know. Everybody else wants to type everything else out. What did I call it? Oh, I should have had capital U. Methods are capitalized. Let's go up and test it. Simulate code. We're compiling. We built the code, we turn on our interface, and there it is. Yellow is still off. We come down here to test mode. We're odd, right? So we're high. Go low, we're even, green. Turn that one. We're odd again. So the red is on. Turn them all off, they all go off. All right. So that code works. So we're looking good. All right. All right. So the challenge for the next time is to modify the sequence, to add another DI, purple, I don't know, pick a color, and to modify the even odd for 4 buttons, right? So I'll leave it up to you. You've now got if else, if else, and the switch case statement. I'll leave it up to you as to which one's the easier to modify, or if you want to play around, go ahead. For extra credit, go ahead and move the other 2 examples down, the LED interlock and the LED sequence 1. Extra credit. Again, be constructive, be flexible, be patient. Things are changing. And for the next lesson, we're going to expand the use of the FRC. We're getting into joysticks and gamepad control. We're also going to introduce a new interface, the smart dashboard and the shuffleboard displays. So be innovative, have fun, and be safe. Follow up. Last time I mentioned that methods should be lower or uppercase. Classes should be uppercase. Methods, variables, objects created from the classes should be lowercase. So just thought I'd clarify that, and we'll see you next time.